right. Okay. Hi. Good afternoon. My name is Jason Butte, and I work at Lawrence Livermore National Laboratory, and I've been the primary developer for our compute side analytics. And so I'll be talking about compute on Kubernetes, and kind of start off a little low level on some decisions we made to implementation wise, and then kind of go high level to how we access the compute services and some user requirements. So when we came into this from kind of just a toy server, we had some initial considerations. We knew we wanted to go microservices. We wanted to run everything in containers. We were looking for something to do resource management and dynamic resource allocation. And so we were also looking, knowing that we wanted to go with containers, something for orchestrating the containers. And so we looked at, Docker Swarm, Google Kubernetes, and then Apache Mesos. And in the end, we decided to go with Kubernetes. The development cycle is very fast. They're pumping out features, and it kind of just made sense. And so with choosing that as our orchestration for containers, I can kind of I'll talk a little bit about our design and how we're utilizing Kubernetes to do resource allocation, dynamic resource allocation. And so there's kind of two services that work together to utilize Kubernetes to do this. And so first we have the provisioner. And so this is mainly a service that actually communicates with Kubernetes itself using a service account to restrict its access. And this is what actually allows the service to allocate resources within the cluster. And then we have the backend, which is actually the implementation specific code that will determine the resources it needs and actually does the computing on the resources once they're allocated. And so kind of looking at the image in the bottom right, WPS requests will come in, it'll be passed on to the provisioner after some validation, and then the provisioner will wait for a backend to become available. And so currently we have one backend, and it's a CDAT X-array implementation. And so once that comes up, the provisioner will pass the WPS message along. It'll actually pass it in a broken down format that's less WPS specific. And the backend will then kind of decide what resources it needs to accomplish this. It may be a global resource that's shared among users or a user-specific resource, which is kind of how we do right now using CDAT and X-array and Dask. And so once the backends decide the resources it needs, it'll ask the provisioner. Provisioner will then communicate with Kubernetes to determine whether the resources can be allocated or not. And then once they're allocated and they're up and stable, the provisioner will let the backend know that it's good to go and move forward with the execution, where then the backend will communicate with, in this example, the Dask scheduler to actually build up a graph of compute operations. And so along with this, the provisioner also monitors Kubernetes to look at the resources that were allocated, and it monitors them for, first off of a time base, so they're not sitting around forever in the case of per user resources. And then once it'll also look at whether the resources are actually being used. And once it decides that, say, they're not being used, it'll reclaim those resources back into the cluster for the next set of jobs or whatever happens to come by. Maybe some other pods that are running within the cluster. And so our backend supports a lot of basic operations like aggregate and subset. We've started supporting max and min, subtract and sum, along with some other basic operations. And then it also supports the ability to connect all these operations together into a workflow to produce more complex operations. And so all of these components all have Prometheus exporters, so we can monitor metrics, the number of requests coming through the provisioner, the number of requests that weren't being allocated on the cluster. and various other metrics. And so with using Kubernetes as our container orchestration and moving forward with that and we're going to be trying to more tightly integrate our WPS compute service into Kubernetes. And so some of the ways that we're looking into this is potentially using Kubernetes operators, which will allow us to define some of these compute resources as custom resource definitions within Kubernetes. And so the one thing Kubernetes does extremely well is manage state, what we expect and what's actually happening in the real world. And so things like jobs being submitted and the state of jobs, it handles that really well. And so we can potentially utilize Kubernetes operators to manage those states. Along with managing processes, you define these in YAML files, upload them to Kubernetes, and then Kubernetes will manage, we'll have all the information to move forward with, say, executing those within the cluster. And along with using Kubernetes operators as, say, a job is defined and containers are spun up, we can then start creating some smart routing where we can have the processes actually executing locally to the data using a federated cluster. And so that kind of leads into another area that we're looking into is a way of, say, federating Kubernetes where we may have two Kubernetes clusters that are located two different data sources, and then we can route the actual processes that operate on that data to the correct clusters. And so some ways that we're looking at doing that is using Kubernetes Federation version 2 API, which is basically the built-in federation for Kubernetes clusters. Another thing we're looking into is ISDIO, where we can kind of create a mesh between multiple clusters and then route the operations depending on which ones are closer to the data and other various metrics that we may use to make those decisions. And then another thing moving forward is continuing testing these operations so we can provide quality, reliable operations on data. And so I'll kind of talk about some user requirements that we've been getting. One of them is custom user processes. So one of the use cases we have involves some complicated binning of data. And so it's been requested that we allow some sort of sandbox where a user could submit a script and then operate on the data. So that's something we are potentially looking into. We've also had requests for advanced processes such as binning and resampling. And both of these are resamplings. Both are fairly hard problems to solve and provide a robust implementation for the user to take advantage of. And then another thing that we've been hearing is we need to make the adoption of WPS a little bit easier. And so right now we're working on providing notebooks that actually implement use cases, user use cases, using the basic operations that we have, and then redistributing those to users to give them an idea of how they can use the service. And then another thing that's been requested is the reproducibility of these operations. Not so much, beyond just submitting a job and then resubmitting the job again and getting the same result, but being able to take what was executed and maybe execute it locally within a Docker container on a user's laptop. And so that's another thing that we're looking into. And then I'll talk about kind of the access that we're providing our users. We have a Jupyter Hub instance that's actually running on Kubernetes alongside the compute services. And so we're providing our users with local access to local data. And we're also providing them with the ESGF Compute API, which is the user API for the WPS services to access remote data. And then we're looking at integrating that more tightly with Jupyter Hub through JupyterLab extensions. And then users also have the Python library, the ESGF Compute API, again, to run locally on their laptop if Jupyter Hub isn't something they want to use, or JupyterLab isn't something they want to use. And that's all I got. Thank you.
Okay, thank you, Jason. So